Hello, geometry students. Mr. Zacek back and better than ever in Unit 8, Lesson 3. We're going to talk about trigonometry, and more specifically, we're going to look at right triangle trigonometry. Okay, so any two triangles that have a pair of congruent acute angles are similar by the angle-angle similarity. So similar right triangles have equivalent ratios for their corresponding sides called trigonometric ratios. Okay, so a part of this here that we're going to be looking at is the acute angles, meaning we're not going to be looking at the 90-degree angle. So the sine, so it's spelled S-I-N-E, but it's sine of angle A is the length of the leg opposite A, which you'll see over here is side A in the triangle, over the length of the hypotenuse, and C is representing the hypotenuse. So sine is I'm going to highlight kind of the key parts for you to remember. Sine is the opposite over the hypotenuse. The cosine of angle A is the length of the leg adjacent to angle A and the length of the hypotenuse, which is B over C in this triangle. And the tangent of angle A is the leg opposite over the leg adjacent to angle A. So we can abbreviate the ratios this way, and so the sine of A is opposite over hypotenuse, the cosine of A is the adjacent over the hypotenuse, and the tangent of A is the opposite over adjacent. So we've got a couple of kind of sayings that people use, ways to remember the ratio. Tom's old aunt sat on her cat and hollered is one. So tangent is opposite over adjacent, sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse, right? Or the other way that people use is Sohcahtoa. Sohcahtoa, it always makes me think like I'm, I don't know, in a fight or something. Sohcahtoa. So those are two kind of common ways. There's other ways. I'm sure if you Google it, you'd find a whole bunch of them. But Tom's old aunt sat on her cat and hollered. Somehow, it's helpful to remember these relationships. I think they're actually on the formula sheet for the year, so you don't really have to. But you're going to use these so much, you'll start to remember it. Now, here's one of the keys that you have to get with this. So when we're labeling the triangle, here's the key point. Okay, so the key point is the opposite and the adjacent depend on which acute angle you use. Okay, so the opposite and the adjacent depend on which acute angle you use. So what we do over here, the hypotenuse is always going to be opposite the 90-degree angle. But notice here, so the way I name it is circle that angle that you have. So the angle is always going to touch the hypotenuse and the adjacent. Adjacent means next to, and that means the remaining side is the opposite. Okay, but what would happen is if we were going to do angle B as an example, okay, now for angle B, this side would be the adjacent and this side over here would be the opposite. So it depends on which angle we're talking about, how we name opposite and adjacent. Okay, it's dependent on that. Big point. Okay, now the final piece here is if we know the sine, cosine, or tangent ratio of an angle, you can use the inverse, which we represent by sine to the -1, cosine to the -1, and tangent to the -1. Now these are the abbreviations: sine, cosine, and tangent. Okay, and sometimes these inverses are also referred to as arc sine, arc cosine, or arc tangent. So what we can do to find it is if the sine of x equals 2/5, then we can go ahead and do the inverse of that, and that will give us the angle. And the way we're going to do that is on the calculator. Okay, so here's some steps here. I want to show you first what we need to do on the calculator with your graphing calculator. So the first thing we want to do is at your home screen, you want to go to your settings, and we're going to go to document setup, or document settings, which would be number 2. And we want to make sure that for the angle that we have here, instead of being in radians, we want it to be in degrees. What I'm going to do is I'm going to make that the default. Okay, so anytime I open up a new document, that becomes it. If you don't make that the default setting, then what happens is it will, if you close the document and you go back and revert to it, it'll change it back to radians. Okay, we'll talk later in the year about what radians are. It's basically another way to measure this. Okay, so step 2, label the hypotenuse, circle the angle, and then we'll set things up in the ratio. So I'll go through it with you here. What are the sine, cosine, and tangent ratios for angle T? Okay, so I'm going to write my little reminder thing here. I'm going to write Tom's old aunt sat on her cat and hollowed. Okay, so here's what are the sine for angle T? Again, remember it depends. So here's what I'm going to do. The first thing I'm going to do is I'm going to label my hypotenuse. Okay, that's opposite the right angle. Now I'm going to circle angle T, and I've already got the hypotenuse. The circle is always going to touch the hypotenuse and the adjacent, and that means the remaining side is our opposite. Okay, so what are the sine? So let's do sine. So sin of T equals, sine is the opposite over the hypotenuse, which is 8/17. Cosine. Cosine of angle T equals, cosine is what? A/h, so that's 15/17. And then the tangent, tan of capital T, is the opposite over the adjacent, which would be 8/15. So we have identified all of those relationships. Okay, let's go ahead. Now, what are the sine, cosine, and tangent ratios for angle G? So angle G, I'm going to circle this up here. I'm going to identify my hypotenuse as 17. That's opposite the right angle. My circle is always going to touch the hypotenuse and the adjacent, and that means the other side over here would be the opposite side. So we got to do the sine of G, the cosine of G, and the tangent of G. Okay, so what is sine? Sine is opposite over the hypotenuse. So that's going to be 15/17. Cosine is the adjacent over the hypotenuse. Cat and hollered, 8/17, or Sohcahtoa, depending on how you do that. And then the tangent is the opposite over the adjacent. Now, one little thing to note here with tangent, see how in tangent here you got 15/8? The only one where the numerator can be bigger than the denominator is the tangent. Because for sine and cosine, they're always being divided by the hypotenuse, and the hypotenuse will always be the longest side that we have there in our diagram. Okay, so how can we use this? So we'll get into some examples here. In 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful and resulted in a tilt of 5 degrees, reduced from 5.5 degrees. Suppose someone drops an object from a tower at a height of 150 feet. How far from the base of the tower will the object land? Round to the nearest foot. Okay, so that's interesting that they changed it that 0.5 degrees. So what we're looking for is, we're looking for this distance down here. I'm going to draw this triangle over here. Draw it a little bit, out of scale. But so we're 150 feet, we got a 5-degree angle, and we're trying to figure out what is this distance over here. Okay, well this is a triangle, right triangle, because we're height, it's perpendicular, trigonometry question. And what do we have here? Well, we got our 5 degrees. This is our hypotenuse over here. This side over here is our adjacent side, and this side is our opposite. So Tom's old aunt sat on her cat and hollowed. Okay, well, what do we know? We're looking for the opposite. We know the adjacent. That means we're going to use tangent. So the tangent of 5 degrees equals the opposite over the adjacent. Okay, so we're going to put this over 1, and now we use the cross product property. So we multiply across. X equals the tangent of 5 times 150. So let's go ahead and pull up our calculator. We've already changed the setting on it. So I'm going to open up a new document, and we'll use a calculator here. So the trig functions here are this button right here, and we're going to go over to tangent. So the tangent of 5, then I'm going to arrow to the right, times 150, all right, is 13.1233. Okay, so X equals 13 point, I have like short-term memory problems or something. 13.1233. Okay, so 0.1233. So round into the nearest foot, so it's approximately 13 feet away from the building. That's interesting. So you're up there. That's how much of a tilt is on there. 13 feet away from the side there because of that 5-degree angle. So that's how we can use right triangle trig to solve that question. Here are some more questions that we have, not in context here, but let's just kind of look at the setup here, okay? So here are the conditions that we have, all right? Number 1, we have a right triangle, okay? Number 2 is we know an angle, okay? We know an acute angle, all right? And we know one side. So these are the conditions that we can use. If we needed to find the side and we know 2 sides, we could use the Pythagorean theorem. Okay, so let's start off here, and let's, I'm just going to write out Tom's old aunt sat on her cat and hollowed. Okay, we'll just get it right in our workspace. So I'm going to start off by identifying that this is the hypotenuse. I'm going to circle my angle. That means this side would be the adjacent, and this would be the opposite. So I'm looking for the opposite, and I know the hypotenuse, that's sine. So the way we write this is Sin of 54 equals the opposite over the hypotenuse. Sometimes helpful for people to write that as over 1, so we cross product property. W equals 17 times the sine of 54. Sometimes you put the number in front just to make sure that you don't confuse it with being like 54 times 17 before you take the sine. So here we go. We got 17. We're going to push that trig button times the sine. Come on. Whoops. Okay, there we go. I think I might have. Sine of 54 is 13.7533. 13.7533. 13.7533. Okay, to the nearest tenth, we'd round that up to 13.8 for W. Okay, and B, use a different color to separate it here. This is our hypotenuse. This is our angle. That means W is our adjacent, and that means 1.0 would be our opposite side. So now, here's what we have going on here. We're looking for the adjacent, and we know the hypotenuse. That's a cosine question. So the cosine of 28 is, cosine is the adjacent over the hypotenuse, which would be, not cosine. What are you doing, Mr. Zacek? Adjacent and opposite. This is a tangent question. Sorry about that. So the tangent of 28 is 1.0 over W. Okay, write this over 1. So this one is an extra step algebraically. So the tangent of 28 times W, 1 times 1 is just going to be 1. And then when we divide this by the tangent of 28, we will have our solution. Okay, so let's see what's 1 divided by the tangent of 28. So 1 divided by trig tangent of 28 is 1.88073. So if we round that, it's going to be 1.9. All right, one more. Let's get a new color. Go green. This is our hypotenuse. Circle our angle. This is our adjacent side. The others are opposite. Now it's adjacent and hypotenuse. This is cosine. So the cosine of 33 equals the adjacent over the hypotenuse. All right, so this is just kind of a one step and multiply. W equals 4.5 times the cosine of 33. So let's see what that comes out to. Is 4.5 times the cosine of 33 is 3.774. So that's going to round up to 3.8. So W would equal 3.8. All right, so that's how we use it to find this. Notice probably the one here, when the variable is in the denominator, that's a two-step solving process. You got to cross product property and then divide. Okay, A and C was just kind of one step and then plug it in and chug it out there. Okay, now a little bit of a different scenario here. Now we're trying to find the angle. Okay, so what's the setup here? Okay, let's recognize the setup. What do we got going on? All right. Number one is we have a right triangle. That's key. Number two is we know two sides. And number three is we need to find an angle. All right. That kind of setup there, that 1, 2, 3, that's going to clue us into trig. So this time we're trying to find the measure of angle x. So we have the hypotenuse. This circle touches the adjacent. And we are looking for the opposite. So Tom's old aunt sat on her cat and hollowed. So what two sides do we know? Let's figure out which trig function we're working with here. Well, opposite and hypotenuse, that's sine. So this is what we're going to work with here. We're going to write the sine of x, S-I-N, equals 6 over 10. Now we have to do the inverse, just like we do in all the other equations. We do the inverse, except for this is a new function. So the way we write the inverse, whatever you do to one side, you have to do to the other side, is 6 over 10. Well, these things over here just cancel each other out, much like taking the square root of x squared does. And this one is now a calculator function for us. So let's figure out how do we get that. It's still our trig button here. On a more traditional calculator, it might be second sine. So we're going to do the inverse sine of 6 divided by 10 is 36.8699. And so to the nearest degree, 36.86, we'd say that's 37 degrees when it gets rounded there. Okay? So let's go ahead and see if we can do another one. We're trying to find x. So x now is up here. So let's label. We got our hypotenuse. We got our adjacent side. This is our opposite. Okay. So we've got Tom's old aunt sat on her cat and hollowed. All right. What two sides do we know? Adjacent and hypotenuse. That means we're dealing with cosine. So the cosine of x equals 15 over 20. Whenever you're trying to find an angle, you're going to do the inverse of the cosine of x equals the inverse cosine of 15 over 20. These two just cancel each other out, and we go back to our calculator. so inverse cosine of, I think it was 15 divided by 20. And here, so 41.4 to the nearest degree is going to be 41. A lot of times, if you're using your phone calculator, you can get these. Most of them have them on there. If you just kind of swipe over, you'll find these things on here. Sometimes the order that you have to do it is a little bit different. So if you want to figure that out, just come in and we can take a look at it and show you if that's possible. Okay. All right, what is y to the nearest degree? So here's our last one. Okay, so y is here. We got our hypotenuse, we got our adjacent, and we got our opposite. So Tom's old aunt, you know what? That's what we need because we know the opposite and the adjacent. So the tangent of y equals 100 over 41. So we're going to do the inverse of the tangent of y equals the inverse tangent of 100 over 41. Okay, these ones over here are going to cancel each other out, and so inverse tangent of 100 divided by 41 is 67.7, so we'd round that up to 68 degrees, okay, to the nearest degree. All right, so there you have it, the two types of things. So we're kind of adding this is a nice tool, and I'll tell you what, this one shows up a lot in a lot of different places. So we'll get a lot of practice working through this, but definitely something that is really important. So if there was any parts of this that were giving you a little bit of trouble, just go back and rewatch this or come in and ask a question. All right, good luck, and I will see you back here soon. Click